Hi, this is Kate, and we're learning about compound inequalities. A typical monthly cell phone bill is at least $35, but no more than $100. Using X to represent the amount of the monthly cell phone bill, what can you conclude? Recall that this symbol means less than, this one means greater than, this one means less than or equal to, and this one means greater than or equal to. So read each statement carefully and make the best choice. Choice D represents our scenario because if the bill is at least $35, that means it's greater than or equal to 35. But if it's no more than 100, that means the bill is less than or equal to 100. Let's talk about how we would graph this situation. We could certainly graph these two inequalities separately. All the values that are greater than or equal to 35, and all the values that are less than or equal to 100. But if we want to represent the typical cell phone bill, we only want to graph the places where these two overlap. What we're talking about here is a conjunction. We're graphing only the values where both conditions are true. The word "and" corresponds with conjunction. So we could write our compound inequality like this. Keep the two statements separate, and then that symbol that looks like an upside down V represents conjunction. However, since the solution set is just one discrete region, all the values between 35 and 100, we can write this as just one statement that's sort of smushed together. What we're going to do is take this x is greater than or equal to 35 and turn it around and write 35 is less than or equal to x. But then x is also less than or equal to 100. So in this way we can write the conjunction as just one statement. Which graph corresponds to -3 is less than n is less than 1? Choice A represents the conjunction. Choice B looks awfully similar, and if you pick choice B, you pick the one where n could also equal -3 or 1. However, since it was -3 was strictly less than n or strictly less than 1, choice A represented that situation. In a guitar playing video game, a special animation is triggered if your audience's enthusiasm goes below 40% or above 85%. If we use A to represent the measure of audience enthusiasm, when is the special animation triggered? Read each statement carefully and make the best choice. Choice B represents this situation because the special animation will be triggered if you're doing very badly, if the enthusiasm is less than 40, or if you're doing very well, if it's greater than 85. If we graph this situation, it's going to look a little bit different. We can certainly graph each inequality separately. A is less than 40 would look like this. A is greater than 85 would look like this. However, in this situation, they don't both have to be true at the same time. We're not going to graph where they overlap. We're going to graph where either condition is true. This is called a disjunction. Disjunction corresponds with the word "or." So it's going to look like this. We include any values on the graph, not just where they overlap. Since the solution is two discrete regions, there's no way we can just write it as one statement like we could with the conjunction. We need to write it as two separate statements. We can either use the word or we can use the symbol for disjunction, which looks like this, kind of like a capital V. Which inequality corresponds to this graph? Read each statement carefully and make the best choice. Choice D represents the graph of all the values that are less than or equal to -3, or all the values that are greater than or equal to 5. Choice B looks awfully similar, except that choice B does not include the -3 and the 5 in the solution. Since those dots were filled in, choice D is the better choice. Sometimes inequalities can be put together in ways that have surprising results. Say I'm thinking of a number that is either less than or equal to 5 or it's greater than or equal to 1. We can get a better handle on this if we graph it. But notice this is a disjunction. So our compound inequality is going to be true wherever the blue or the green touch, not just where they overlap. So what are the solutions to this compound inequality? Since we're not just looking for where they overlap, but anywhere that the blue or the green touch, for the disjunction, all the values on the number line are going to make it true. Okay, let's say I'm thinking of a number that is both less than or equal to 0 and it's greater than or equal to 3. We can get a better handle on this if we graph it. Notice that this is a conjunction. So the solutions to this compound inequality will be where the blue and the green overlap. So what are the solutions? Of course, since the blue and the green don't overlap at all and we're looking for the conjunction, there are no solutions to this compound inequality. So to summarize the difference between a conjunction and a disjunction, the symbols look like this, upside down V, or you can think of it as a capital A without the horizontal bar. And the disjunction symbol looks like this, like a V. Conjunction corresponds with the word and. It's true where both of the individual inequalities are true, and if you look at the graph, it's true where they overlap. A disjunction corresponds with the word or. It's true where either part is true. The graph of a conjunction often looks like this. It encompasses all the values in between two values, in between A and B. And we can write the conjunction as a single statement. A is less than X, and X is also less than B. The graph of a disjunction often looks like this. Since it's two distinct regions, we can't just write it as one statement. We need to write it as two separate statements, all the values that are less than A, or all the values that are greater than B. This is Kate, and you've been learning about compound inequalities.